Now we have to be continually go with that next kind of that approach. It's called model free approach. So there we have to derive certain optimal policy without learning the model. In that model based approach, we are having certain policy, but the model already know what policy should obtained or what policy should be followed. But in model free approach, without learning that model, we have to be devise certain optimal policy. Example, LMS and then temporal difference approach. So these two are the examples of that model free approach in reinforcement learning. And another one type of the learning is called that passive learning and then so active learning. So the agent imply the watches the world during the transition and it tries to learn the utilities in the various states. So this is that passive learning. So the meaning is we are having that is the mobile phone and we are having that clock, and if you are installing varieties of the clocks for the varieties of world region, and then when you are traveling to that particular geolocation, automatically your clock is getting to be that updated. So this is called that passive learning. By understanding of that geo-tag situation and position, what time that has been followed there, so that has been displayed in your mobile phone. And next one, that is active learning. So there the agent not watches simply but also acts for that environment. So according to that environment, so that's that particular learning environment has to act. So these are all the types of that learning. Number one, the two approaches, model based approach and then so model free approach. And in that learning method, there is the two varieties of that learning. One is called the passive learning and another one is called the active learning. So now we have to see how the reward that has been given for that agent. So here we are having the two animal. So number one is the fox and another one is the tiger. So there is the so many rewards is there. The fox is having two setup of rewards, and then the tiger is having the four setup of the rewards. So obtaining that reward from the tiger, that is the little bit difficult because the tiger is an opponent for the fox. So when the fox when the fox reaches to the tiger's region, and then the fox will capture the food without knowing the tiger, and then the fox will receive that good reward from the tiger section. So this is called that reward maximization. So these two animals are the predators, but even though the fox is not the food for that tiger, and also tiger is not the food for the fox. So this is the phenomena that has been applied here. The thing is, for which animal will gain more rewards by getting its food. Okay, so so in this case there is the two parameters. One is called exploration. That means to search and capture more information about the environment. So it is called, that is the exploration of that environment. And then so number two is called the exploitation. So the exploitation means already known information to maximize the rewards. Already I know, so what will next to me, but in order to maximize the rewards, we have to be go with the exploitation. So exploration and exploitation. And the next one, we have to be see about the reinforcement learning model. So the each percept is enough to determine the state. The state is that accessible. So when we have to be apply that agent task, we have to be go with that optimal policy by mapping the states of that environment for the actions of that agent, and also that maximize long run measure of that reward. So it can be modeled with that MDP. This is called Markov decision process. The Markov decision process is a mathematical framework for modeling decision making. So that is mapping a solution in the reinforcement learning. So what will be that MTP model? So the MTP model is having the STAR. So what we already saw in that previous episodes, and this MTP model will happen between the environment and then agent. So environment is understandable by that agent by the term of the state, and it's implement that certain action and it receives the rewards from that environment. In between of the state and an action, we are having one function is called the transition function. So that is called that T. So this is the probability of that transition. So in that transition we have to be applied. So how that action that has been performed by that agent. The formula is saying the capital T of S small s and small a and then small s. When we have to be apply the conditional probability with that S dash and with that S and A, we have to be get the transition effect of T of S comma A, that should implies that S inverse. So the reward function for that S comma A, that has to be implied by or of S comma A, that means states and then action that leads to that rewards. So for the transition that has to be S dash, and then for the reward it has to be go for that OR. And so this is an example how that MDP that has been worked with that these parameters. So here we are having that is the graph. So STUV, so these are all the nodes, and we are having the rewards as that edges. So it may be in Indian rupee we have to be considered. The thing is the S has to reaches to the destination B. So that is the edge. So that is the destination. So in what way it has to go? So that is the varieties of the rewards. So in case S is traveling one step without traversing to that another nodes, it's getting the negative rewards of that minus 22. So when it is traveling with that SU and TB, so there is also negative rewards. When the S is traversed through that SUB, we are getting that is that very limited amount of the rewards, that's only that 40. But the S that has been traversed through STB, that means that is the most optimal, and it will get the rewards of that 90. So the agent has to opt to travel to G through by T. So S to T we are having that 14, and from T to 51 we are sorry, T to V we are having that 51. That is the maximum hours of 65 is there. So that can able to earn by that agent. So this is the mechanism of awarding that reward. So on that next episode we have to be see about the further parameters of reinforcement learning.